In a previous video, I talked a little bit about canceling logarithms, or where a logarithm cancels out. And that's when you have a situation where maybe you have a logarithm of base A, and then the value is also of base A. So it could be like a to a power 2. So in this particular case, we would say, well, the logarithm, the exponent required to raise a to become a squared is simply 2. And that's canceling out those logarithms. So that's a cancellation property. Some other places where we see it are things like this. So log 10 log 3. Now, if this is 10 raised to the power log 3, it's a little bit complicated to think about, but if I go ahead and put the actual common log base in there, this becomes, and bear with my words, 10 raised to the power of the exponent required to bring 10 to 3. So it's 10 to the power required to make 10 become 3. Well, I think that just means that these two things are going to cancel, and we'll be left with 3. 10 raised to the power required to raise 10 to 3. Neat. That's a cancellation property. Now, other common places you see it are with e and the common logarithm. Sorry, the natural logarithm. So e raised to the power required to raise e to 4 is 4. E to a power of ln, cancel. And then we can also do this conversely. We can say ln e to the power 4. Well, that's also going to be equal to 4. Because just like a common logarithm has an assumed base of 10, a natural logarithm is really just this. And so that's why those would cancel and we would be left with 4. It's just a shorter way of writing that. And so that's a little video about the cancellation forms for logarithms.